There we go.
Hello, everyone, and welcome to another K6 Office Hours. I'm Nicole van der Hoeven.
I'm Paul Balogh.
And today we have two guests from an awesome company. Would you please introduce yourselves? Let's start with Ken.
Hey, Ken Hamric with Tracetest, currently down in Pensacola, Florida, on a boat that's kind of rocking.
So you are on a boat.
It's actually a virtual background. So
awesome.
Hey, hello everyone. I'm Oscar Reyes. I'm engineer at Tracetest, and I'm from Mexico. I'm glad to be here.
Awesome.
Awesome. It's great to have you both here. Thank you for joining us. We've been wanting you folks on here for a while.
Yeah, and especially now with the work that Oscar that you've been doing here lately, and got to meet up with you guys. Yeah, Ken, I got to at least see you and talk to you a little bit at KubeCon in Detroit. What was that? October, I guess.
October, yeah. It was. It was actually. I'll cover it kind of in the slides, but it's kind of what started me thinking about: is there a spot for load testing and trace testing? Is there something that makes sense there? And with based on Oscar's work, I'm pretty excited.
Yeah, no, that's cool.
That's really awesome. I'm a load tester by profession, so I'm really excited to hear what you think about trace-based testing. Why don't you start with telling us what trace test is? What do you folks do?
Sure. So we one way I like to explain it is most test tools, K6 to part, but it goes deeper than that. But let's pick on Postman for a minute. If I named Postman, I would call it response test. You trigger a test, you get a response, you write assertions against it, which is great. But in today's distributed world, there's other questions. I might put something on an async message queue, and I've got 3 processes that pull it off. How do I know those processes worked? What Tracetest allows you to do is also, we don't just get back the response. We also get back the full system trace from your observability data. And we allow you to create assertions based on any of the information throughout this distributed trace. So a kind of a deep system / integration / end-to-end test.
Cool. Yeah. And I don't know, was it just me or did you freeze up there? Because are we all having connectivity issues today? I mean, so this might be an exciting session for those of you watching. It's
yeah, who's going to pop off next?
Oscar and Nicole may just have to take over if I'm freezing up.
Well, we'll see about that. We're going to switch to Spanish if that's the case.
Yeah, we can change that to Spanish.
Mi amo Pablo.
So again, I think I really want to hear, I'm excited to see this because I think the problem with load testing is that often it's really like a black box. So you get almost like a yes or no, like did it perform, did it not perform? But even if the answer is no, you don't automatically find out why. And really that's the thing that you do want to find out. And so it's not really just a matter of running the test. It's also a matter of the troubleshooting and trying to find out what went wrong exactly. And it seems like that's what Tracetest really is about.
Yeah, exactly. So, and I think towards the end we can talk about some, simple trace tests that are super powerful. For example, you can say, hey, if I got 20 microservices involved in this system, I'm doing a load test across it. In about 10 lines of code, you can add in Tracetest to say, let's say using gRPC, if any of my gRPC status codes throughout this process are not equal to 0, fail the test. And that's just so it's not looking shallowly at the top level, it's looking throughout every microservice and enabling you to put assertions against it. So.
That is cool. I mean, because I mean, from what I've seen, everything with all the different pieces, you can have a mix of whether it's the Kafka topics, ensuring that messages are being picked up in the overall scheme of things, and gRPC and HTTP requests and all that. It's pretty cool. So Oscar's done well.
He has. I'm writing on his work. So
Yes.
And it has been pretty fun to work with the K6 extension. Documentation is great, and it's really
Good.
useful to kind of just have a starting point to write your own customization on top of the already existing binaries. So yeah, it's been really awesome to work with the K6 stuff.
Oh, it's funny. I
So-
just saw that Mustafa chimed in there. He heard the word Kafka. That's a trigger word for him. He's actually the author. He's a K6 employee as well, but he's also the author of the XK6 Kafka extension. So
Very nice.
What made you decide to build an integration with K6? There are lots of other load testing tools out there.
There are, K6. First of all, well, and I've got a picture from KubeCon, but at our booth, so we got a booth at Tracetest booth at KubeCon, and people would walk up to us, and the one most frequently asked question was, "What is Tracetest?" Okay. The number 2 question was, once they understood what Tracetest was, we had 5 people ask us, "Well, do you work with K6?" And so that started me thinking, perhaps we should work with K6. And then the second thing that occurred that really formatted it was I saw the XK6 tracing extension that was,
Yep.
and I saw it and I saw how it worked. So it allows you to trigger a trace from a K6 test, and then I saw it returned the the parent trace IDs, and I was like, hey, if we had a parent trace ID, it's pretty easy for us to make trace tests, accept that as the source of, hey, you're going to base your test on this trace ID, and go out, grab the trace, and run tests against it. And I said that to Oscar, and this was one of the few times he didn't roll his eyes and go, Ken, you don't have it right. That doesn't work. So, yeah. So actually, but part of it, I will say the documentations were great. When I was looking at K6, I could easily.
Oops, and
Okay, I think we
yeah.
did lose him.
Yeah. So yeah. No. Well, I'll finish that sentence then. That thought, about the great documentation. Yeah. No, that's something that we definitely pride ourselves on, and it's never perfect though. So there's always updates that need to be made. So
yeah. So what happened is that we based the initial implementation on based on the tracing extension. We forked that into our own repo. We worked based on that, and then as soon as we have like an initial version, we moved that to the KubeShop under the KubeShop organization. But it's pretty much reusing some of the parts that we saw you guys did for the tracing extension.
yeah, it's kind of funny when the author of the XK6 distributed tracing extension, the original one, when I mentioned that you'd picked it up and we're going to add on to it, he's like, hey, why are they forking it? He's like, we're nice. We can, just add to it. We'll play well together. It's all about the big tent with Grafana and, making sure that there's plenty of space on the playground for all of us. So.
Yeah, maybe in the future we can do something like that for sure. Yes.
Yeah. No.
Exciting. As we know that it was a pretty initial version, that we still trying to support more things like gRPC or like other protocols, not only HTTP, right? So yeah, that's the idea.
That's awesome.
Okay, so we have a question from Manish Correa, who asks, does Tracetest come with a community version?
Yeah, so currently, so just to talk about a little bit, Tracetest is an open source tool. So that means that the code base is public, and you can install it based on the documentation in different many ways. Like we have Docker, we have a Helm chart for support Kubernetes, and we are really heavily trying to support other types of deployments like AWS Fargate or anywhere you want to use Tracetest. So yes, right now, the version that we have for Tracetest is a community version. You can use it in your own setup deployment. We don't have like a paid premium version, at least not yet.
Cool. Okay, so are there plans to have that ultimately a software as a service version?
Well, I guess that would be more a question for Ken.
For Ken, yeah.
Yes.
Well, while he's gone.
So yeah, to be honest, I would just prefer for him to answer that when he's back.
Hey.
Again.
Hey, Ken.
We learned all your secrets now while you were gone. So
Hey guys,
Yeah,
oh
so while
no,
you were gone, Oscar was
I
making
moved over.
promises
Yeah.
about what you're going to release tomorrow and stuff.
Oh, good.
Why don't we jump into your slides before anything else goes
We'll get
wrong?
started.
exactly.
Okay, all right. And I moved over to my phone connection, so who knows?
See, I was
Let's
worried I
see.
was going to have to do that myself.
Slides.
A question maybe that we can tackle while you're doing that. Elibariki John asks, Tracetest can work on monolithic application?
Yes. So the idea is that if you have an your application instrumented with OpenTelemetry, you can always use Tracetest. You can install Tracetest in a Docker container separately to your monolith application and have the traces sent to the hotel collector or any data store that connects to Tracetest. So it's not only for distributed systems, but it can work with monolithic systems as well.
Yeah, but it really shines with the distributed stuff, right?
Yeah, of
That's
course. Yeah,
where
that's kind of
yeah.
where it gets more complex. It's where you require more observability and that kind of stuff, right?
So it looks like Ken is still trying to get back on his his normal Wi-Fi.
Yeah.
But while we're waiting for him, why don't we talk about tracing in general? Like back up just a little bit and talk about, why tracing is even like you were saying that tracing is more valuable when we're testing distributed applications. Why is that? And what can tracing show for monolithic applications?
Yeah, I mean, at one point, I was trying to do an interview for one of the fan companies, and one of the initial question was how to solve a problem about event-driven kind of messaging between different services, right? So you have this type of supermarket or like driver applications where you have to manage a lot of events from when the user requests either the food from the restaurant or a driver a car. It's just a lot of processes that need to happen in the backend that are running asynchronously, and you need to coordinate everything, right? So when a bug happens within those type of systems, it can be really difficult to understand what's going on. So with observability and trace-based testing, what you can do is just kind of open your whole mind to what is going on within those systems, because you have all of the spans, all of the steps, and everything is just described as a graph where you can follow the whole request through all of the system and requests and services that have been using it. And not only that, but also databases or queues or gRPC, every type of protocol you can think of. It's supported by OpenTelemetry now. So it just opens more possibilities to understand how the information flows within your system, I guess.
Well, yeah. And while Ken's still getting connected back up too, though, I was going to say we suggest that. We have our XK6 disruptor now, which is kind of just for chaos testing and for like cutting out certain aspects of an entire pipeline. That would be an awesome way to awesome thing to hook into the Tracetest as well. So for demos and that. So, but anyway, but now Ken's back.
And I might be stable now. I deleted the entire Wi-Fi profile and re-added it, and I'm back on what.
Did you bring the boat closer to shore now?
Normally it's normally a stable connection, so I apologize. Maybe I should
That's
get to
right.
the slides, the stuff I'm going to be doing, which is the least important stuff, the showing the real code.
Go for it.
But I'll get started. Can y'all see my screen?
There we go.
We can now, yes.
Perfect. Okay. So I'm going to do some background stuff. Starting off, what are we trying to accomplish with K6 is a great load testing tool. Trace-based testing enables you to do these deep tests. And with the two products together, we're trying to bring where you can do distributed testing load testing across your entire distributed system and ask questions, not just at the top where you hit the API, but deeply throughout the system. And I think you'll see as we go through it, the hard part is getting distributed tracing set up in your system. But once you have distributed tracing set up, installing, using, and getting value out of Tracetest is super easy. So why do we build integration? Well, have already covered that, so I'm going to skip that section. We're going to cover a couple. I'm going to be using the word tracing, distributed tracing a lot, trace-based testing a lot. So I want to show you what those things are. And then I'll show you a demo of Tracetest as part of that, just so you can see a basic trace test being created. And then I'm going to hand it over to Oscar. He's going to do an in-depth look at K6 with Tracetest with code. And then we'll do recaps and questions. So that was us at KubeCon, getting asked about K6 continually. And we mentioned the K6 distributed tracing extension, which allows you to, if you import the tracing extension, it allows you to send propagators so you can get a trace back from your K6 test and get your trace IDs. And when I saw that, maybe was that beginning of November, I think?
Probably when we talked about it anyway, when you and I did.
I think so. That's when I remember seeing it, and I was like, okay, we could definitely do this. All right, so just a couple of background slides. There's only 9 slides total, so we're about halfway through. What is distributed? Well, these slides are always. I want to get to the software. So, what is distributed tracing? It is a method to really look at one transaction and get information about exactly what happened with that transaction as it goes through your distributed system. So in this case, on the left-hand side, it's supposed to represent your system with microservices. And then the right-hand side shows you what you get from a distributed trace. You can see that the A service was called first, and looks like a synchronous system because it starts, all the processes underneath happen, and then it returns at the very end. So it's synchronous. I can tell the order of operations. A calls B, that calls C. C probably returns to B, and I can look over here and say, yep, B calls C and then returns to B, then B calls D. And I can kind of pick that out by looking at the trace. And then E is called afterwards. If I were to, in any kind of tool that can look at a distributed trace, like looking at Grafana, and I look at the E span, I'm going to see what are called attributes for it. So it's information like how long did it take? What was the response code? I can manually instrument it to include other data, even custom variables. You could put a is okay variable inside of an attribute. Distributed tracing gives you this great information and is typically used by SREs and DevOps in production to look at how things are going. Tracetest believes that that instrumentation you've added to your code can also be used in earlier stages in the testing phase of working with systems. We enable integration system and end-to-end tests to be easily built by relying on that observability data contained in a distributed trace. We are out on GitHub. We're an open source project. You can install it in Docker Kubernetes. It's got both a UI and a CLI, and you can author tests either directly in the UI, or you can bring up TextPad and author your own test in a YAML format, which I'll show you. And it works with your existing tracing solution. So if you've got Grafana, you've got your system set up for distributed tracing, you can hook Tracetest up to it and start using it.
Sweet.
This is it's a kind of an eye chart, a lot going on. We're going to be looking at one particular example throughout. I think Oscar uses this one also, and I'm going to use it to demonstrate Tracetest. It's 2 microservices. We being Oscar, built a sample microservice, which we call the PMA. It's the Poke Shop microservice app. And it reaches out to, in this case, we're doing an import. So we're going to do a post to this endpoint. We can see it over here. We do a post to the API. We take the information. I think there's like a validation step, and then we take the information, We put a message on RabbitQ, an import message, and then we just return a 200 or 201. We say, we got the message, we're going to process it. We've got other backend systems that are going to run with that message off the message queue asynchronously. So we see our service number 2, which is our worker service. It dequeues the message. It reaches out to an external service, the Poke shop or the Poke API, hands it the ID, gets back some information about the Pokemon, and then we write it to a database. And then there's a little bit of other caching processes happening there, but this is the basic flow. And we're going to go through this a couple of times. So 2 microservices. This one just gets the API and throws it on a queue. This one pulls it off the queue, reaches out to external service, and writes it to a database. And this instrumented app is available on PokeShop. What's it written in, Oscar?
That's TypeScript, Node.js and TypeScript.
Okay, cool.
I was going to say, Nicole's probably going to start using the PokeShop for her
I'll
demonstration.
do you
soon.
one better. I already have used this for my demonstrations.
Very
Not
nice.
the Poke
Yeah,
Shop,
I
but I
love
used
it.
Poke API. I demonstrated chaos testing on using New Relic at the time. So I wholly approve of your choice. I was just looking over from my Pikachu ears.
Yeah.
This was all Oscar. Oscar had to tell me what a Pokemon was, so I actually did know. All right, let's take a look at some code. So that's all. That's about it for the slides. Okay, so this is Tracetest. You install Tracetest onto either Docker or Kubernetes. When you launch it, you come up. This is what you'll see. I'm just going to run through how you create a Tracetest and then hand things over to Oscar. So I'm going to go through a create flow. I'm going to make a new test.
Would it be possible to increase the size on that just a bit?
Yep.
Awesome.
Is that better?
Perfect. Thank you.
Okay. Good call. Okay, so I'm going to create a test. In this example, with most tests, you say, how am I going to trigger it? In this case, I'm going to trigger it with a HTTP request. You could paste in a curl command, etc. And I'm going to cheat. We've got the PokeShop example kind of built into our app, so it's easy for us to use. I'm going to do an import. So I'd name the test. I'm going to do a post against a Pokemon import and pass it ID of 52. And now I'm going to create the test, which actually runs it for the first time. So it reaches out to the PokeShop API. It hit that post import, which put something on message queue, and it returned super quick. It returned 160 milliseconds. And we got our body data back, and we see it worked. It was 200. The difference, and this, you could do the same thing in Postman. What's different about Tracetest is we also captured the trace. And here we can see the trace. We can see it in a couple of different views. We can see it more traditionally in this type of view. We tend to like the graph view better, but either one's good. And what Tracetest allows you to do is create tests. So I'm going to take the very top node where we did the post to Pokemon. I'm going to do the most basic tests that everybody does. I want to make sure we get the right status code back. So I see our status code. I'm going to add a test spec and say, we expect the status code to equal 200 for this post. And we'll save that. And that's a test that almost any test tool in the world can do. What's unique about Tracetest is we take the post, we validate it, we put it on message queue, we pull it off a message queue, we have this import Pokemon process, and then we reach out to external service. So way down in the guts of the system, has anybody ever failed when they're having to rely on an external service and reaching out to it? Is that a likely spot of failure? Probably. They could change their API, they could be down, etc.
I've had that issue today with my internet service.
Exactly. Once you start relying on more than one thing, things go bad. Permutations get you.
Yeah.
Okay. Yep. So we're going to select this this, and we're going to say the response body that we get back, we expect it to return meoth. And we're going to save that. I'm going to go ahead and add one more. I'm going to say, hey, we expect the status code on this. This is HTTP call. So we expect it to return a 200 also. So we'll add a couple assertions to it, and we'll save it. And I'm going to do just one more, and then I'm going to start handing things over to Oscar. Once we've got the data, we're going to write into the database some information. And I'd like to make sure our database calls are happening quick. So I'm going to add a check on this one to say the time it takes to write to this database call better be less than, we'll say, 250 milliseconds. And I could save this, but I really would like to check not just this one database span to make sure it's fast, but I really like every database span to be fast. And if the process changes in 2 months and you do another query, I'd like to check that it's fast too. So a kind of unique capability of Tracetest is we have this concept of a selector. What are we focused on? And right now, this is focusing on this one node or this one span. I can change it. I'm going to say I want to test every database span. So I'm going to do that by removing some criteria. And I'm going to say I want to focus on every database span. We now see we're focused on 11 different things, and I want all of them to happen in less than 250 milliseconds. So I'm going to save that test. I can publish the test, and I can take the test definition file, which is in YAML, and it has things like, what is my trigger? I'm posting to this import with this body, and then my test specs. So which has selectors and what the checks are, selector, what the check is, selector, what the check is. I could download that, put it in GitHub, run it under via the CLI, etc. And that is my 3 or 4 minute kind of review of what does Tracetest do.
No, that is
Awesome.
very cool.
I just also wanted to share, like, this is the actual video I was talking about, and just to prove how completely I agree with what you were saying, Ken. I called it Schrodinger's Pokemon because until you actually see inside the box, you don't know if it's alive or dead.
Yep. No, it's pretty interesting capability that allows you to ask deep questions. Black box or white box testing almost has bad connotations. Everybody's like, no, you want black box testing, you want everything isolated. But in this distributed world, if all your testing is that top part, there's some issues with it, particularly when you have async processes. It really, in my mind, it falls apart. So.
Yeah. And a lot of that is just driven on strictly adding in the OpenTelemetry libraries so that your code is instrumented, which everybody should be doing anyway. Whether they're using trace-based testing or not, everybody should have that.
Absolutely. And then,
so maybe let's talk about the requirements for using Tracetest. And Oscar, let me know if this is part of your demo. I don't want to preempt it.
It is not, but I don't know if can we just address it now, or should we wait to the end so we can continue with the extension first?
Maybe we can just talk a bit about the requirements now.
Mm-hmm. Ken, do you want to?
Yeah, just the install. You can install it into Docker, or you can install it into Kubernetes. There's not a lot to the system. It's a program written in Go, and then it also stores the persist data in a Postgres database. So that's kind of the install will install both those things. You have the option of installing a little bit more. If you never use OpenTelemetry, it'll install our example app and the pieces. I think it installs Jaeger by default, so that you kind of can quickly get a up and running system if you're just playing around. But it should take 5 minutes to install it. So it's real simple.
So we have the basic installation through the CLI, as Ken said. We also have a bunch of examples within the documentation repo that you can use based on your existing setup. For instance, we have for Node, we have for Golang, we have for different data sources like Tempo, Jaeger. So depending on what setup you're using, we might have something for you already, so you won't start from scratch, basically. And also, kind of a side thing is that Pokcho was also built to kind of guide users to understand how to start instrumenting your an ODS application. So you can use that as a guide as well. Or more, there's the OTel demo, the OpenTelemetry demo, that is a community thing that is uses a bunch of different programming languages that you can guide your instrumentation based on each of the different services that they have built. Yeah.
Question from Monish here. I am a QA. How can I conclude if my application code has already added or been configured with OpenTelemetry instrumentation?
I would tend to say talk to your DevOps or SREs, and they're going to probably be the people that drove it, because in production, without that kind of observability, you can't tell what's going on.
You won't see it.
They're probably the ones that have added it, so they'd be the ones to ask. And your developers probably have added code in to support it, so they would probably also know.
Yeah. And then I was going to add too, though, like in the case of in that map that you showed, the process map, it had those the database connections. So if the database client didn't have the observability instrumentation embedded in it, you just wouldn't see that. So it just, yeah.
I will also add that as a tester, this is something that I feel very strongly about and against, really, because this is the way that the question was asked is a very, it's a very clear indication that there are silos. And I think that as testers, we should have access to these environments and check for ourselves. I mean, obviously communicate with people and get the right access and permissions, but I love that you're asking these questions, and I would really encourage you to also ask for more access, because gone are the days when testers should be only testing black box.
Right. It's not thrown over the wall and somebody else handles it. Yep.
Yeah. We should be able to see that ourselves. Anyway, Oscar, how about are you ready for the demo?
Sure thing, yes. Yeah, you want to switch to my screen?
Yes, we should see it now.
Awesome. Okay, so I'm basically going to be using the same example as Ken was displaying a moment ago, where we have this import Pokemon process. It just has the same, the facade worker API that just returns a 201 status code, and then the synchronous process. So I'm just going to go a little bit deeper and kind of the setup that I have. The difference is that Ken was using our beta environment, and now I'm using like one of the setups for or examples that we have in the repo. So I'm just going to show you that by opening Docker. So I'm using Docker Compose to set up the services. I'm using Tempo as my main data store, as well as Jaeger to visualize the things as part of the UI. And as you can see here, this is going to be very, very important, is the worker. This is the actual service that is microservice that is pulling the data from the Poke API and storing into the database. So now, based on that, I'm going to start looking at how the K6 extension, how it works. So let me see if the font from my Visual Studio Code is big enough for you guys to see. Okay, so what I have here is a pretty basic K6 script. What it does is using the HTTP library to trigger the requests. It is sending the request to the Pokcho API that I have running locally, and it's using the Poke ID or number 6, that is Charizard, and it's sending the HTTP request using the post method with the payload, the headers, and everything. And I have two checks. The first check is that the status is 200, and the second one is that the body matches the ID. So this is just like an echo thing where I send ID and I expect that to be returned as part of the body. So I'm going to be running this this example as you normally would with any K6 binary. So I'm just going to be running the script. It's called import Pokemon. As you can see, it's part of the examples folder. So Tracetest examples, Tracetest K6, and you'll find a detailed way of getting started with these two tools combined. So now back to the test, we see that the body is returned 200 and the body matches the ID. And I see the kind of summary from K6 about the duration and the load test results. Now, what I'm going to do now is that I'm going to be killing the worker. So I'm going to go back to my Docker dashboard, and I'm going to stop the worker. So as you can see, it's no longer running. And I'm going to run the tests again. In this case, what I expect to see is the same result. So everything is green. I see 200, I see the body matches ID, and this is because the initial API is returning the expected result, right? We don't know what's going on behind after the initial message queue. So what I'm going to do is that I'm going to copy the extended script utilizing the Tracetest binary extension, and I'm going to rerun the test. So I'm just going to copy this, copy paste for a moment. I'm going to go step by step how to do it yourself. But now what I'm going to do is run it again. And one thing I'm going to be adding is the output, the new output called XK6 trace test that you can be using that this is going to basically collect the traces that are generated by the HTTP client and automatically, based on the test ID that you choose, running the tests from trace test. So by executing this command, this updated command with the binary and the output, the tests are going to finish, and it's going to wait a little bit longer because it's trying to process the traces and the results from Tracetest. So as you can see, I have an error that I didn't have before, and the error is calling out that there are 6 jobs that are failing from Tracetest. And I can see the summary from the failed test from Tracetest. But not only that, I can have the URL that goes straight to my UI. So this is actually a test that was triggered using K6, and this is the result. And now combining the two tools together. So if I go to the test section that Ken just showed, I have 2 assertions here, 2 test specs. The first one is that I'm validating that there is a span called import Pokemon, that at least one of them exists. And now I see that the result is 0 because the worker is not up. And then the second test spec that I have is that there is a database operation that saves the Pokemon into the database, the table that we're using, and the name is Charizard. So I'm not finding these 2 spans, and as you can see, K6 from the response, it just looks that it's correct. But when you look deeper into what is going on within the system, you can see this other side with the different results. The worker is not functioning as expected. So just to validate that this is working as expected, I'm going to rerun the demo, the worker. And as you can see, the trace only has the half of the information. It just goes all the way to sending the message queue from the API. Now that I have started the worker again, I'm going to rerun my tests, and we can see what happened. The idea is that we will get all successful tests, and we can see the links and that kind of stuff to validate the results within the UI. So I see green, I don't see any panic errors or anything like that. And I see the summary says successful. And if I go to any of the tests, I will see that everything is green. So, and even you can see it by the size of the trace that is bigger, it has more spans, which include the worker section as well. So we can see this. We have actually an import Pokemon span. We have the database operation, it exists right here, and the name of Charizard. So everything is working as expected. And this kind of showcases the power that you can have with the 2 tools combined. Now, in a real scenario, what if you push the worker to the limit, and instead of manually killing the worker by a specific load test, you actually kill the worker or kill a process in the background? Well, you can identify those issues with combining Tracetest with K6. Okay, so
I'm just gonna stop for a second. I think that's cool. So you're doing load tests. You've got a lot of distributed systems, a lot of microservices, and your load tests kill something way back in the system.
Yeah.
This gives you a way to detect that type of failure.
And that's what I don't know if when you were having the connectivity issues, Ken, but that's where I was kind of mentioning we have the XK6 Disruptor, which is our chaos product that we're working on, and that's one of those things where it's like you could put those together and see the issues.
It'd be pretty cool.
That puppy's is excited.
Sorry.
Dog's excited about K6 and Tracetest.
Right? I mean, it's I'd be barking too.
After seeing Oscar's demo, I start doing that also. So.
So I guess I would like to stop to see if there's any questions or something like that. So if not, I can continue looking at the code and how you can start adding this extension to your scripts and that kind of stuff.
That's good.
Now let's go.
Okay, so let's go back to the code, right? The important thing, the code. So what changes have I done to the script to utilize Tracetest? So the first thing is that, and kind of following the pattern that the tracing extension had, is that we are overriding the HTTP client to have more to create these traces IDs based on the configuration from the user in terms of the propagators and the propagators that will be adding the header, the parent trace ID and that kind of stuff to the request. And also you'll find a Tracetest instance class that you can be creating instances based on that. So what I'm doing here is that to create a Tracetest instance, you have to initialize it with the server URL. So in this case, if you're running that in a Kubernetes instance or you're running it locally, you can just add the direct URL to that server. And this is not the only way that you can configure it. You can also configure it through the environment variables or the output. So in this case, if I so from my terminal, I could just do equals and then the server URL instead. So that should also work. So in that case, you can, instead of hard coding the value, you can use it from environment variables or directly from the output. Then the test ID. So the test ID, it should match whatever you have in Tracetest. So in this case, I'm basically grabbing the ID from the URL. I'm pasting it here. This can also be configured through, actually what you can do is just create the whole definition as part of this file. So as Ken showed, you can grab the definition from the run and then go to the options and then test definition. And then you can see the whole YAML object. If we go back and look at the code, we have a test in the examples that you can be using. That is under test YAML. And by using the CLI, you can inject this test into your Tracetest instance. That's part of the steps that we described in this example folder. So we have the test or test ID, and then we can start looking at the parameters for the test. So we have the Pokemon ID, the URL, and then we create the instance for the HTTP library. So you can add things like the propagators. So we have some supported propagators like W3C, B3, Jaeger, the most common ones. We have them supported. And also you can add the Tracetest configuration as part of the HTTP object. So you can do Tracetest, and then you can do test ID. what this is going to do is that every HTTP request that you send is going to be using the same test ID to run the validation after the initial request. But if you wanted that to happen differently for each of the requests, let's say you have a GET request and you have a POST and you have a PUT or whatever, instead of using the same test, you can do it through the parameters of the request itself. So let's say for the specific HTTP post, I want a different test ID than what I have in the main instance. So that's also configurable. So you can decide from where you want to add your test ID and which one do you want to use. And the last part that you have to do is pretty similar to what you would expect in the for the regular test, where you just be sending the HTTP request and expecting the results. So there's not a huge change here, rather than just the configuration for Tracetest. Now, the last two steps are somewhat important. The first one is that we allow you to decide if you want to break the script, the tests, based on the Tracetest results or not. So if you want this to happen in your CI/CD process, you can add this function from the Tracetest instance to the teardown life cycle for K6 to say, hey, validate the results before closing finalizing the run. If you add this, then if one of the tests fails, the whole run will be return a non-zero status. If you remove this, you'll see still this. You can see still the summary. You can see the URLs, that kind of stuff, but we won't interfere with the status, the return status.
Right. So wasn't this Paul's idea?
Yeah, exactly. One of the Paul's comments was this, and I like this approach because you can decide where you want it or not, or just want the results, right? It's not like we actually make the users have it or yep. And the last thing is handle the summary. So K6 already handles like the basic summary for the load test results. What I'm doing here is that you can combine the default summary with the trace test information and print both at the same time. So by using the trace test instance and just calling the summary method, it will return everything that you saw in the console. So it will be the same thing as this. So it will be successful, the successful tests, the total runs. So I had 6 runs, successful runs and failed runs, and each of the steps will have its own kind of row with the results. So that's what you get from the trace test summary. And then the way that you want to add it to the response is just std out. And we also support a JSON output. So in case that you want to kind of chain processes, let's say you have the K6 extension and then running the load tests, and then you have the following process that utilizes the output from Tracetest to do something else. You can also do it through JSON, the JSON output. And you can decide where and how you want to add it, right? This is just an example Tracetest JSON. Then that it will generate, let me see if I have it here. Well, I don't see it, but it just generate the response and print it into a JSON file. So as you can see, these are tools that are optional, and you can decide you wanted to use them or not. And one other thing is that if you want to skip the output, if you don't want to use the output, you can also execute the test manually. So from the trace test instance, you can do run test, and it will get some of the parameters. So for instance, you have to add the trace ID, and the trace ID as the HTTP library is configured, is excellent to generate the traces. You can get the trace from the response. You can do trace ID, and then from here you can add metadata like the request information or things like that. So in that case, actually, I think this is the trace ID goes here, and then we have the traces information over here. So if you don't want to use the output, you want to manually trigger the runs yourself using the script, you can do that by just utilizing this method from the Tracetest instance. And you can skip the using the output if you want to. So there's multiple ways that you can configure a Tracetest extension to work with your scripts. We don't have like specific way of doing. You can, depending on your use case and what you want, you can use the extension. You can combine the extension with others. So as the powerful K6, you can just combine a bunch of extensions, bundle them together, and use them. So the idea is that just by using Tracetest, you don't have to stop using the rest of the extensions that you're already using.
Yep. Oh, that's cool.
We actually have a question about that. So this is from Alien FPV. Is Tracetest also good for browser level testing?
Ooh, Ken, do you want to answer that?
I was going to let you answer that one. That's part of my dream. So we want to get there. So we're integrating it with other browser-based test tools, whether it's Cypress or whatever.
So maybe
looking at. So it's not, I'd say today, not really, but it's something we're very interested in. So.
So
That's
maybe
another
you
collab.
don't already know. Yeah, because we actually have XK6 browser, and our goal is to gain feature parity with Playwright.
Yep.
Nice.
Maybe we'll take a look at that then, because that would be an easy way to enable it. So.
Yeah. Yeah.
So I guess the answer is not yet,
Not yet.
but it's technically possible. Yeah.
Yeah. So what I can see is that the OpenTelemetry demo, community demo, one part of it is it has an XJS application fully instrumented from the browser side. So we know that there's ways to generate traces starting from the browser. It's just a matter of how we want to kind of start doing the test based on user interactivity with the application.
Well, now, and we also have Grafana now has the Flare product, which it's a front end JavaScript library, which will add the trace IDs and such as well. So,
nice.
Yeah, we just recently had that on office hours as well. So it's cool stuff.
I mean, there's a world. There is a world out there. We have a lot of new tools.
Yeah. So I guess we should just put you on the schedule for the next office hours, and I don't know, we'll give you a month, and then you can demonstrate it.
Good to me. So
yeah.
So when it comes to load testing, what is your recommended behavior? Do you expect that Tracetest would be used even in very high volume load tests?
Yeah, I'll cover that. We talked a lot when we were implementing, and we're like, okay, we got to make sure that load tests or Tracetest tests are not run as part of the load. We can't influence how long your test takes to run at all. So by default, we're set up to post process. So you run the load tests with K6, and then we get stuff, and then we go run Tracetest, and it might take a minute, but it's not going to impact the. You're not load testing. Part of your load test doesn't become how well can Tracetest handle load. So we're out of the equation. So.
Just one thing. I think we can stop sharing my screen.
We did.
Okay, awesome. Thank you.
Yeah. So you're recommending, I guess the issue is also the back end, right? So one of the questions that we had was also, how can you change out the distributed tracing back end?
Yep. And I could show that real quick if you wanted to see it. We just recently did a lot of
great.
work. Just did a lot of work, so I'd love to show that. I'm super proud of it.
I did happen to notice it.
Yep. Under Tracetest, we've added settings, and this is where we configure what your backend data store is. So you can change to another one,
wow.
alter it. Something we added that is super helpful. If you're entering a lot of these parameters and you're not sure if you have it right, we added this. So I'll break it. We added this test connection. and it's going to come up, and it does a series of tests to tell you, try to help you. Hey, I tried to reach out to this thing, and it timed out. I couldn't reach out to it. And now if I try to change it back, I think that was 5, and I test it. It was able to connect, it got authenticated, and it was able to fetch tests. So it says, hey, we are connected successfully to your backend data store.
Nice.
Wow, that's really easy.
Yeah.
That's cool.
I mean, but you should have been showing tempo right there, though. I'm
Well,
a
we should have
little
been.
disappointed, though.
Exactly.
You'd think I'm in sales or something. I'm really not.
And just to make sure we have an example get started folder for tempo. And you just a Docker Compose image. You can just run Docker Compose up, and you'll have everything running.
And we love tempo. Is one of the first 3 that we integrated with. There's Jaeger, tempo, and can't remember what else we came out of the box with. So.
Oh, that's awesome. It truly is. It's a very, very cool product, and then it's a unique take on it, and then on it all, and it's very cool what you guys have put together.
Thank you.
Kudos. Yeah. And I was just going to ask too, because one of the things I know with the extensions ecosystem, one of our problems is we have so many extensions. And in that, people were hoping that we would have this, all these Docker images of all these different permutations and all that. Just out of curiosity, do you publish a publicly accessible image of K6 with the XK6 Tracetest extension embedded in it? Do you have anything like that? So somebody could pull that down. They wouldn't have to worry about building their own K6 with XK6. They already have your official version.
I think we don't have it as part of the documentation or anything like that. But what you can do is go to the, I will be posting the main repo that we use for the extension. And as part of each of the releases, there's a binary. We're generating the binary and putting it as part of the release.
Oh, okay, cool.
So you can use download it from there as well.
Perfect. So that way then, folks don't have to worry about having their Go environment set up or all that to be able to build. Because exactly. I know it's a problem sometimes. So cool. So that makes it even easier for folks to check it out and try it, give it a spin.
And the extension is part of the official documentation as well. So you can go to the extension stocks. And you'll
awesome. Awesome. Yeah. So if they want to go gung ho and bring in the XK6 browser and start playing around with both, then they'll have to build that on their own. But cool.
I'm also curious, do you have any insight into whether your users are mainly using Tracetest in production or in test environments? Is there a heavy skew one way or the other?
It'd be both. We're still fairly new, so we started. Our first MVP was out in June. Did tons of work through the fall. The configuration screens you just saw. I think we released that January 3rd. So I think in the November, December timeframe was really the time that Tracetest has become mature enough to do a job, and it is fully functional. So we're still in that early adopter mode. So I expect it to be in the test environment. There's some interesting things in a production environment where you can have tests defined with variables. So you can kind of use it as an ad hoc testing tool. If you're in production, you want to make sure this post process is working. So you run Tracetest test. It prompts you for what ID Pokemon do you want to go after. And then you can run your tests, and your tests will verify the things that should work. So you get a pass or fail, and you'd see exactly which parts failed. So I think there's some interesting use cases in production, but
that sounds like something that would integrate really well with what Paul was mentioning earlier with Grafana Faro, some sort of, RUM or synthetic monitoring kind of test, which is not so much about the load, but they're usually in production.
Yeah.
Maybe that's our next integration.
There you go. Yeah. So Nicole and I, we tend to make a lot of work for other people that are guests on these sessions. So I don't know, just always happens to work out that way. So yeah,
Oscar's one of the quickest devs I've ever worked with, so
That's-
he can handle it all. So.
well, I know when we were discussing some of the changes as you were creating the extension, I know it's like, yeah, you came back pretty quick with some of these updates. And it's like, wow. So, you know.
So where should folks go to if they want to just get started with the K6 and Tracetest integration? Where's the best place for them to go?
Maybe I've shared a screen with them because I had to get one more slide in before we're done. That has some
Sure.
links on it, if you could share that.
Yes.
So we have, if you go to tracetest.io, you can get to our GitHub, which will get you to our extension. It also has a link to our Discord channel where we have conversations with people using the tool and trying it. And then there's the link to the XK6 Tracetest extension, and our Tracetest is out on GitHub. And we would love you to any ideas you have for Tracetest with the extension or in general. We'd love for you to create an issue, tell us about it. I think Paul submitted a pull request today for a documentation error we had, which we appreciate that. And also, if you get out there, give us a star. We like to. It's our ego boost. We see our stars, right. Get happy.
Yeah, we got to see if we can't get you up into an extra digit.
Good. That would be awesome.
Yeah.
Awesome. Thank you both so much for coming to share this with us. I think this is just one of the many examples of the awesome extension community that K6 has. And this is something that adds real value to people.
Definitely. Yeah, I can't say enough about it. It's what I've seen so far has been really impressive, and looking forward to working with y'all more.
Yep, we enjoyed working with you and appreciate the help as we're developing. We're bugging you with questions, so thank you.
All right, thank you both, and thank you everybody for watching, and we'll see you next week. Have a good weekend.
Thanks,
Bye,
everyone.
everyone.